Hi there. It's Professor Monty. Let's look at the graphs of base E exponential and logarithmic functions. So when we're talking base E exponential, we're talking about y equals e to the x, and base E for logarithmic is going to be ln. Y equals ln of x. We're going to look at that graph as well. So what I've done is I've plugged in some values for x, for y equals e to the x. So x is 2, 1, 0, -1, and -2. I used my calculator. These numbers are rounded to one decimal place. So e to the second power is about 7.4. E to the first power is about 2.7, etc. If I graph those to see what the graph of e to the x looks like, let's say, okay, we go over to 2, we go up to 7.4. Let's go 1, 2, 3, 4, 5, 6, 7, 8. 7.4 is about here. At 1, I'm at 2.7. At 0, I'm at 1. -1, -2, -1, I'm at 0.4, and then 0.1. So I look at this graph of e to the x, y equals e to the x, and it looks something like this. It's our typical exponential graph. So there's y equals e to the x. Now, typical exponential looks like a hockey stick or a banana. That's my typical graph. If I do translations, reflections, I can do different things with that, but all my basic y equals e to the x graphs are going to look like this. It looks very much like 2 to the x because it's almost 2.7 to the x, because e, remember, is about 2.7 something. Okay, so that's my exponential e to the x. What does the log look like? Well, remember, that's the same as saying log base e of x. That's what ln means. If I change this to exponential, I get e to the y equals x, which is this function I've just swapped where the x and y are. So I can take all these, swap x and y, and essentially what that does here is it takes that graph and it flips it around this line y equals x. So it's the reflection across there. So instead of 2, 7.4, I'm going to have 7.4, 2. And I've got 2.71, I've got 1, 0, I've got 0.4, -1, 0.1, -2, and I can graph that as that reflection. So if I go 2, 3, 4, 5, 6, 7, 8, 7.42, I'm up about here. 2.71, 1, 0, 0, -1, 0.4, -1, and 0.1, -2. So again, it has that exponential or logarithmic shape, the same hockey stick, the same banana, but it's a reflection across that line y equals x. So this is the graph y equals ln of x. Or again, that's just x equals e to the y. Okay, so those are my graphs. The exponential graph looks like the typical exponential graph we're used to, and ln of x looks like the typical ln graph we're used to. It's just got a different base, the base of e, or about 2.7. All right, that's the idea. You can still use your reflections, translations, all those things with these, but that's the two graphs, and that's how they're related.